Today we're going to talk about units of measurement. We'll just start at the beginning with the International System of Measurement, often referred to as the SI. It is based on the metric system, and you're probably very familiar with this, but volume we measure in liters, symbolized like this: mass, kilograms, length, meters, time in seconds, and temperature in Kelvin. Those are the basic units that we use in science. And there are some other parts to the SI system, other units of measurement. You're welcome to look into those for advanced proficiency. Some basic prefixes. You definitely know some of these right in here. We have micro. Well, you may or may not use that. Know that 10 to the negative sixth. It's represented like this with the Greek letter mu. We have 10 to the negative 3, stands for milli. 10 to the negative 2 for centa. 10 to the negative 1 deci. 10 to the third is kila. Here are some examples of these. Take a moment just to study this chart. We don't really get too much into some of these, but sometimes when we look at very, very small numbers, you'll see nano and pico, 10 to the negative 9th and 10 to the negative 12th. I don't expect you to have those memorized, but certainly everything between milli and kilo you should definitely know, like the back of your hand. These other ones I'll always provide a reference, and in books will always have a reference as well. Your textbook has appendices that list the prefixes, the symbols, and the factor that is involved. And these are some good examples to help you understand those and be familiar with them. So let's just do a few simple conversions. This should be a review for you. When we're going this way, the units are getting smaller. A millimeter is very tiny. A kilometer is very large. We're getting larger going this way. When we look at different units, here these are prefixes, but the units themselves are interchangeable. We could be talking about meters, we could be talking about liters, we could be talking about grams, and we would just apply the correct prefix to each of those. When we want to convert, say, kilometers to centimeters, we will convert this direction from the kilometers to the centimeters. And if you'll remember, a very convenient way of doing that is simply moving the decimal place that many, or the decimal point that many places. Let's look at that in the next slide. So let's say we have 1 kilometer, and we'd like to know how many centimeters that is. Well, 1 kilometer is going to be 1, 2, 3, 4, 5 decimal places moved. 1, 2, 3, 4. If we move the decimal place 5 places to the right, 1 kilometer shows that we have 100,000 centimeters. We can, of course, substitute grams or liters for those meters as well. Here's another way to think about it. 1 kilometer equals how many centimeters? I guess I just showed that. Another way to think about it, 1 meter equals 1,000 millimeters. We could think about that as 1/1000th of a meter would be 10 to the negative third meter would be 1 millimeter. That would be moving the decimal point to the left instead of to the right. Uncertainty in measurements. That's a very important topic to discuss because we measure a lot in science. For example, if you look at this graduated cylinder here, we have some liquid in there. We know for a fact that we have at least 1.1 milliliters. But we have a little more than that. It's not 1.1, it's 1.1 plus a little bit more. It's not 1.2 because that would be up here. Remember, we always measure to the bottom of the meniscus. It's somewhere in between 1.1 and 1.2. It looks a little bit like it's 1.15, halfway in between, but it could be 1.14 or 1.16. So there's a little bit of uncertainty there. That last digit represents that uncertainty. We can write it another way or think about it another way. 1.15 plus or minus 0.01 milliliters. It's our uncertain digit. So when you record measurement, you record all of the certain numbers. 1.1 is certain. Plus, you record the first uncertain number. That would be the 0.05 here. So we're going to record 1.15. That is the first uncertain number. All of these numbers, or these digits together, they're called significant figures. So now you try. What is your recorded measurement here of this dotted line? So we know the recorded measurement equals all of the certain numbers plus the first uncertain number, called significant figures. So we have a certain number of 2.5, and now we have this uncertain number here. We can say 2.55. What if we use this ruler? What could we record for our measurement? It would be 2 would be our certain. This is going to be uncertain, isn't it? It will be 2.5. Notice that our certainty depends greatly on our measuring devices and how finely tuned they are. Let's take a look at temperature. When we measure temperature, there are 3 different scales we can choose from: Celsius, Fahrenheit, Kelvin. Kelvin is the SI unit of measurement. And it's important to note that Celsius degrees and Kelvin degrees are the same. They rise and fall in the same increments. The Fahrenheit degrees are not the same. They are different. So differences between these scales also, the 0 points are different on each one of the scales. If you look here, 0 degrees Fahrenheit is not the same as 0 degrees Celsius, certainly not the same as 0 degrees Kelvin. So how do we convert between the Fahrenheit and Celsius scales? Something that is a convenient tool and that you will need to know. Adjust first for the different size units, and then second, adjust for the different 0 points. And this is how we do it. We have the temperature in Fahrenheit here is equal to 1.8 times the temperature Celsius. This adjusts for the different size of degree. Then we're going to adjust for the different 0 point by adding 32 degrees to it. So how would that look mathematically? If we have an example, 25 degrees Celsius would be what temperature on the Fahrenheit scale? We would just plug in 25 degrees Celsius for the temperature in Celsius here and carry out the math. 1.80 times 25, get that answer, add 32 to it, and that gives us 77 degrees Fahrenheit. So now you try. You read 98.6 Fahrenheit on your thermometer when you're taking your temperature. What temperature would that be on the Celsius scale? Answer would be 37 degrees Celsius. So now, how do we convert between Celsius and Kelvin scales? That's actually really easy. We only need to adjust for the different 0 points. The temperature in Celsius plus 273 is equal to the temperature Kelvin. So if we give an example, convert 25 degrees Celsius into Kelvin, we simply plug in 25 degrees Celsius to the temperature in Celsius, add 273 to it, that gives us the temperature in Kelvin, 298 Kelvin. We don't denote Kelvin with a little circular degree sign, just for your information. One more item to discuss would be density. Density is a measurement that we use a lot. It actually involves 2 other measurements. Density equals mass divided by volume. And if you just think about that, when you think about density, it is the amount or the mass of some substance per the amount of volume it occupies. So we will always measure this in the mass in grams or centimeters cubed, and we measure the volume in milliliters. So an example, pretty easy problem. If mercury has a density of 13.6 grams per milliliter, what volume would 255 grams of it occupy? And this is just kind of a plug and chug problem. It isn't too difficult. 13.6 grams per milliliter, if we write that in for the density value, just follow this formula here. 13.6 grams per milliliter is the density. Density equals the mass, which we're told is 255 grams, divided by the volume. Now if you do a little cross multiplication, remember that, volume times 13.6 grams per milliliter is going to be equal to 255 grams times 1. We have then our volume equal to 255 grams divided by 13.6 grams per milliliter, and that gives us 16.5 milliliters. Feel free to work on some more of those problems out of your textbook. Advanced ideas, find out about other SI units of measurement. That's always interesting to look up. Research the history behind the implementation of the SI units, and that's interesting as well. So I look forward to seeing what you come up with, and we'll see you in class.